So chapter 1 was on algebra. So we're just going to do a few questions. So question 1 says simplify. So we could have something just like this, just numbers. Okay, that was in the first section. So how would we do this? We need to... Can we cross multiply in this question? No. When can we cross multiply? It has to be an equal sign. It's when you're solving for x. You can't cross multiply when there's just numbers. So we're going to do a common denominator. So 1 over 2, common denominator, 10. So we would multiply this by 5. And the 3 over 5 we're going to multiply by 2. So 5 over 10 plus 6 over 10 divided by 4 over 3. So that's 11 over 10 divided by 4 over 3. Okay, so we've got a fraction over a fraction. You take the top one and multiply by the reciprocal of the bottom. Now, at this point, you could say to yourself, does this simplify? Can we cross anything off before making the numbers bigger? And the answer is no. There's no 11 or 3. So this would be 33 over 40, and that would be the answer. We've done this one so many times. Please don't ever get it wrong again. This is what? 5 minus 4. No, no, no. Square root of 9, which is 3. It is not 5 minus 4. All right, you have to have it multiply before you can take the square root. You can't have a plus or minus. All right, what about other roots? So say we had the cube root of negative 8 plus 4 times the square root of 16. Now be careful when you look at something like this to really look at the notation. Like that 3 is smaller and it's raised up a little bit, so that's part of the radical sign, where this 4 is in front, it's bigger. Okay, and when it's typed, that's more obvious, but you have to look because you don't want to mess that part up. What's the cube root of negative 8? Negative 2. This is 4 times the square root of 16. So minus 2 plus 16 is 14. So this is the cube root of 27x cubed over 8x to the 6th. So there's 2 ways to do this, and sometimes you have to do it one way and sometimes you have to do it the other way. So it's a cube root. So what you're going to look at is, first, you could maybe simplify everything in the bracket, cross things off, make it smaller inside the bracket. That's usually a good technique. The other thing is you have to remember that you have to do the cube root of all of these. There's no plus or minus sign, so you can just do the cube root of everything. Does everything that's in there have a cube root that works nice? Yeah. And could we simplify the inside? Would that also work? What would simplify in here? The x's. The 27 and 8 don't simplify. They have nothing in common. But the x, if we canceled out x's, how many are we left with? So the 27, we can't do anything with that, and the 8. Now there's 3 x's on top and 6 on the bottom. So 3 cancel, that leaves 3 on the bottom. Now because there's no plus or minus signs, we can do the cube root of 27, the cube root of 8, and the cube root of x cubed. Cube root of 27 is 3, 2, and x. So 3 over 2x would be the answer. Okay, so the next part, question 2, solve for x. So those would all be just those small one-point questions, right? You work it out, you get the answer, you put the answer in the box. Okay? Solve for x could also be that type if they're a smaller solve for x. Actually, any solve for x could be that. So let's say, for example, solve for x, so just linear. Work out all your brackets. So 4x plus 4, 3x plus 15, right? Make sure that those numbers go into the brackets. 4x plus 2 and 3x plus 15. Okay, so now what? Move the x's to one side and the numbers to the other. So x equals 13, and that would be the answer. What about this one? Difference of squares. Now what if I had put the question this way? Yeah, I would still do a difference of squares. There is the other way that you've probably done it before, which would be like x equals plus or minus the square root of 9. And I don't really ever do it that way myself. You can, because people often forget the plus or minus. But if you always move it over, make it equal 0, so then you do the difference of squares, you'll get x plus 3 equals 0, and x minus 3 equals 0, which you could write as plus or minus if you wanted to. It's the same thing. Just be careful of doing to solve cube roots, we do the cube root of both sides, but you don't need a plus or minus. It's just whatever sign it is, so you don't need to remember anything. But with a square root, we have to remember plus or minus, and so I don't usually ever do that. I just do difference of squares. You could use quadratic equation with any of the quadratics too, and that'll give you the right answer. That would be strange to do the quadratic equation for, but you could. What about this one? No solution, and that would be the solution. That would be what you would write in the box, would be no solution. Nothing to show, nothing to do. But like I said, like those one-point questions, I don't even mark your work. You can put anything off to the side. I'm marking what's in the box only, and I don't look at the sides, 1 or nothing. Right. Okay, right here. Move the 11 over. Always has to equal 0 before you factor, use quadratic. And then you would say, okay, well, does this factor? Two numbers that multiply to give 16, 8 and 2. And what if it didn't factor? What would we do? Quadratic equation, yeah. There's our answer. So here, solve for x. So we cross multiply, right? X equals 2 on to x plus 1. X minus 2x equals 2. So minus x equals 2, or x is minus 2. And you just have to sort of remember that there could be restrictions, and I could just ask for restrictions as well. I could give a fraction and say, what are the restrictions on this, and not even ask you to do anything else. That would be a legitimate question, like for 1 point. So what do we need to remember here? What are the restrictions? X cannot equal -1, right, because the bottom of this can't be 0. That's x plus 1 equals 0. If you solve that, you would get -1, and we say, well, it can't be because it's on the bottom of a fraction. So you have to remember that x can't be -1. So we got -2, so that's okay, because it's not -1. So you'd have to remember that if you're asked about a fraction. That's supposed to be a minus. That's a minus sign. Okay, so x squared over x plus 1 minus x over 2. What's the restriction on this? It's still -1, so x can't be -1. So when we find our answer, we just don't want that one. Okay. Now, how do we do this? Move one to the other side, exactly. You could do common denominator, but the other side is just a 0. This is not really 3 terms. It's really only 2. The other one's 0. So if it were 3 terms and that was not a 0, you would do common denominator. But here where it's 0, it's easier just to move one to the other side and then cross multiply. So 2 times x squared equals x times x plus 1. So 2x squared equals x squared plus x. Move everything to one side. So x squared minus x equals 0. Now what? Yeah, factor, which would be a common factor or a quadratic equation, but we can factor a common factor x. This gives us x equals 0, and this one gives us x equals 1. Neither of them are -1, so they're okay. So that's our 2 solutions. Okay, so question 3. Solve for x and draw the number or the number line, the solution on a number line. Okay, so question 1. So you don't just rearrange this. What you do when there's a quadratic and an inequality is we change its sign to an equal sign. We go back to the original question later, but this process to solve this is to set it equal to 5 and solve as if that's your question. So then what you're doing is finding where the two sides are equal. So x squared minus 4 minus 5, so x squared minus 9. So we get x equals minus 3 and x equals plus 3. So we get these 2 answers. And then what do we do with those? We're trying to find not which, when we plug these in, they're going to get 5. That's what's happening. We found where does this side equal 5. We want to know where does this side is less than 5, not where it's equal to 5. So we can test these. This isn't the solution on a number line, this is the test on a number line. So what we do is test, these are where it's equal to 5, so we test a number in between, a number bigger, 5, 10, whatever, a number smaller. We test each of them, and we see which one works. Right? Where is it less than 5? So if we plug 0 in, 0 squared minus 4 less than 5? Is that true? Yeah. Here, if we plug 5 in, 5 squared minus 4 less than 5? 25 minus 4? Is that less than 5? No. What about over here? Minus 5 squared is still 25. So that doesn't work. So, what's our solution? So our solution is between -3 and 3. Equal signs because there was equal signs. Always the smaller one first, the bigger one second, and the signs always point down. That's how you would write it, in between. And to draw that on a number line, you would do a new number line, not use that one. We color these in, and then you make that line a little wider to show that that's the solution. So that's what we would be looking for. So in inequalities as well, we could have something like this. An absolute value is greater than or less than. So what about an absolute value greater than? Just like this one above, we had to rewrite it first and solve it. So we're going to do the same thing here, but there was a way to rewrite these. So when you have an absolute value of whatever is less than a number, we would rewrite it. Less than means, let's say we had absolute value of x less than 3. So less than 3 means between -3 and 3, it's in here. And when it's absolute value greater than a number, it meant on the outsides, here and here. So less than is in between, because the numbers are smaller than 3, the distance, right? Because an absolute value is the distance, and these mean the distance is bigger than 3, 4, 5, 6, or -4, 5, 6. Those are bigger. So here we're saying greater than 2. So what I usually do is just off to the side. Okay, say -2 and 2, we want to go these directions, bigger than 2. So we write, instead of just x, we say x plus 1 is less than -2. That's this side. And then x plus 1 is greater than 2 is over here. And then we've got 2 equations to solve. So x, and these don't have a quadratic in them, there's no squared, so you can just rearrange them. You could do the same thing, change it to an equal sign and test, but when there's no quadratic, you can just solve it as it is. So you just rearrange it. And then the other one, be careful. When do we flip the signs? Only when you divide both sides by negative. You change the sign. Otherwise, just make sure your sign's always going the same as you go down. And because this was greater, they should end up on the outside, your answer, or you did something wrong. So when you go to draw this, -3, and 1, empty circles because there was no equal sign. And our answer is x is less than -3, or x is greater than 1, or because they don't overlap, and that would be your answer. So we could do the same thing, but with a less than, so that would be the other case. So you would say first, okay, it's between -1 and 1, and we want in between with these colored in because there's an equal sign. And then you write it in between. So 2x plus 3 is in between -1 and 1. And then to solve it, we break it up into 2 with an and in between. So -1 is less than 2x plus 3, and 2x plus 3 is less than or equal to 1. And then we do the same thing that we did up here, solve it, and then put it back together. So -1 minus 3. I left that on that side, so when I divide, it won't be negative. We're putting them back together this way anyway, so you can leave it in that form on this side. And you put them back together. So you don't really need to flip that back around. You can if you want to. If you were to flip that around, it would look like, be careful when you flip these things. X, the bigger part is open towards the X. X is bigger than -2. That's on this side of -2. Just if you were to flip that around. Not necessary though. Okay, so find the equational lines through the point -1, 2, and perpendicular to y equals -3x plus 1. So perpendicular, so the slope of this line is -3, and the perpendicular slope would be positive. You change the sign and do the reciprocal, 1/3. So we want to use the slope perpendicular to that and the point -1, 2 to find an equation. So an equation of a line. Plug this information in and rearrange it. So y minus 2, 1/3 onto x minus a -1. One-third x plus 1/3, that's multiplying. Leave the y by itself. Join these together, common denominator. That's like a 2/1, so we want to multiply that by 3. So we'll have 1/3 plus 6/3, which is 7/3. So, intersection point, there was two ways to do. We're just going to do the easier one, just or the quicker one, just for time factors. But you could have the equations in the other form that you do elimination. Remember, there was two different ways we could solve a system, so elimination or substitution. If they're both in the form y equals, then to solve, we would just set them equal to each other. So we get x equals 2, and then what do we do with that? Plug it back in to either equation, doesn't matter which one. Same with elimination, you're going to find either an x or a y, and then you plug it back into either equation to solve for the other. So if we plug it in to the x plus 3, we'll have 2 plus 3, which is 5. If we plugged it in here, we'd also get 5. So our intersection point has to be written as a point when you write that answer in. So if this were a one-point question, I was just looking for the answer, you'd have to put that in as a point in your box. Okay. Okay, so the next question, graph. So we'll do just a couple graphs. So what type of equation is this? Just a straight line, linear equation. The only points we need are the x and y intercepts. We need 2 points to draw a line. This one is a line. And so we can find our x and y intercepts and then plot those. So our x-intercept, we're going to let y equal 0. Y equals 0 is the second one here, so 1/2. And our y-intercept, we're going to let x equal 0. Just like on the test, you would have a grid, okay, on the final exam for you to put the answer in. So 0, -1, and 1/2, 0. Write the points in for full marks. We look for that, okay, on the graph. So your intercepts or any other important points on a straight line, the intercepts are the only important points. So you find 2 points and draw your line. B. So I just put also complete the square. So you could be asked to complete the square on a quadratic with or without the graph. Okay, you just complete the square, would be putting it in this form. But for this one, what we need for a parabola is the vertex, which we can just read off as what? +2, whatever makes this 0, and 4. We need the x-intercepts. That's where y equals 0. Now, if you're thinking about it, remember what I said, when you go to graph these, if you put your vertex in, so 2, 4, 1, 2, 1, 2, 3, 4 is up here. Does this open up or down? up. What kind of intercepts are there going to be? Just y, no x. So when you go to solve this, or you don't because you know there is none, how do you solve this? You work it all out? This is longer, and that's what I'm saying. It's best, it's much more work if you try to find this. If you plot it and know there's none, and you avoid doing that work, that's better. Here, what we do is we FOIL this out. I'm just going to do it quickly to show you. So you would write your two brackets, FOIL that out. Add the 4 on. Then you would try to factor. Doesn't factor. Nope. And then you'd use the quadratic equation. And what happens? Minus b plus or minus b squared minus 4 times a times c all over 2. We get a negative under the square root, so nope, none that way, and then you conclude there's none. But you've done all this work, FOILed it out, tried to factor, then used the quadratic equation, all to do something that you could have just realized when you found the vertex. Said it's not going to go through the x, so I don't need to find them. Okay, so don't do all that work for nothing. It's not wrong, it's just a lot of extra work. So we need the y-intercept. And then we would graph it. So our y-intercept is 8. Let's just go 4, 8. And this is 2, 4. And you can make it nice and smooth.